All right, let's talk about system reliability. It's this invisible force that's basically holding our entire digital world together. It's super, super important, so let's just dive right in. Okay, you know the feeling. We have all been there. Your computer just crashes, and all that hard work you just did, poof, gone. It's so annoying, right? It's that awful sinking feeling in your stomach, a total personal disaster. But now, let's just scale that up. Imagine that same thing happening, but not to your laptop. Imagine it happening at a hospital or a bank or, to the air traffic control systems. Suddenly, we're not talking about a lost essay anymore. We're talking about medical records, your money, even people's lives. The stakes just get incredibly high, incredibly fast. And this gets us to the absolute core of what we're talking about today. Here's the hard truth. All systems can fail. It doesn't matter how perfectly they're built, they're all vulnerable. So failure isn't really a question of if, it's a question of when. The real question is, what are you going to do about it? I mean, the list of things that can take a system down is just huge. You've got the obvious stuff, like a hard drive just deciding to die. But it could also be a tiny hidden bug in the software, or something as simple as human error. Someone accidentally pulls the plug. And then you have the really scary stuff, right? Malicious attacks, or even natural disasters like fires or floods. These systems are basically getting attacked from every possible angle.
Okay, so with all that coming at you, where do you even start? How do you protect against all of that? Well, it turns out you start with the most basic, common sense idea in the world. You make a copy.
Yeah, we all know the word backup, but really all it is a copy of your stuff, your data, your files, stored somewhere else, somewhere safe. Think of it like your get out of jail free card. When something gets messed up or you delete the wrong thing, the backup is what saves you. But here's the thing, not all backups are the same. You've got two main types. First, there's the full backup, and it's exactly what it sounds like. It copies everything, the whole shebang. It's super thorough, but man, it can be slow. Then you've got the incremental backup. This one's a bit smarter. It only copies the files that are new or the ones that have changed since the last time you did a backup. And because of that, it's way, way faster. Look, just having a backup isn't the whole story. You need a procedure, a solid plan. For one, somebody has to be responsible for it. You can't just hope it gets done. You also need a schedule. You got to do it regularly. And this next one is absolutely crucial. You have to keep a copy off-site, somewhere else entirely. Because let's be real, a backup sitting right next to the computer that's currently on fire, yeah, that's not going to help you much, is it? All right, so backups are amazing for recovering after something goes wrong. They're reactive. But what if you could build a system that's so tough it might not even fail in the first place? This is where we get into the next level of defense, moving from being reactive to being proactive. And the magic word here is redundancy. It's really just having extras of everything. It's like having a spare tire in your trunk. You have extra hardware, duplicate software, copies of your data, all just sitting on standby, ready to take over the instant the main one fails. App developer Lorna Mitchell puts it perfectly. She says to think of it like a highway. If you've only got one lane open and suddenly there's a ton of traffic, what happens? Total gridlock. Redundancy, she says, is like having extra lanes that you can open up whenever you need them. It just keeps everything flowing smoothly. And you see this play out at a massive scale with companies like Twitter. An engineer there, James Harlow, talks about over-provisioning. Basically, they intentionally run way more servers than they actually need at any given time. So if one of those servers suddenly dies, no big deal. The others just pick up the slack. And the best part? For you, the user, it's completely seamless. The service just keeps on going without a single hiccup. So all these ideas, they fall under this bigger design philosophy called fault-tolerant design. And the core idea is simple. You just accept that things are going to fail. So you design the system from the ground up to handle those failures gracefully. A perfect example you've probably seen is with your word processor. You know how when it crashes and you reopen it, it says, hey, I've got a recovered version of your file. That is failing gracefully. It didn't lose all your work. Okay, but what happens when it's not just one server failing? What about a true disaster? A huge power outage that takes out the whole building, a fire, a flood, something that wipes out your primary systems and your redundant ones? For that, you need more than just spare parts. You need a playbook for what to do when everything goes wrong. And that playbook is called a disaster recovery plan. It's literally the step-by-step guide for how to bring everything back to life after a catastrophe. It's the emergency binder you pull off the shelf so that when, everything has hit the fan, you're not just running around trying to figure it out on the fly. And this isn't just some abstract theory. There are concrete steps. A developer like Lorna Mitchell would, for example, first reinstate the platform, basically set up a whole new virtual environment. Then you deploy the code. You put the application onto that new environment. Next, you restore the data from that all-important offsite backup. And finally, you just remap all the addresses to point everyone to the new, shiny working system. It's a clear, practiced set of steps. Okay, so you've done it all. You've got your backups, you've got redundancy, you've even got a disaster recovery plan. But how do you know any of it actually works? You can't just wait for a real disaster to find out, right? You can't just cross your fingers and hope it all kicks in. The answer, of course, is testing. And I mean rigorous, relentless testing. You have to test everything. You do unit testing to check the tiny individual pieces. You do validation testing to make sure it can handle the right kind of data. You do volume testing, where you just throw an insane amount of data and the users add it to see if it breaks. And then you do beta testing, where you give it to real people and let them find all the weird bugs you never even thought of. And there's this amazing real-world example of this in action: Twitter during the US elections. See, back in 2008, Twitter basically fell over. It just couldn't handle the traffic. Fast forward to 2012, after 4 years of working on exactly this stuff, reliability, redundancy, testing, they faced traffic that was 1,000 times bigger. And what happened? Not a single hiccup, no downtime. That is just a monumental engineering achievement. And this really brings us full circle, because all of this stuff we've been talking about, backups, redundancy, disaster recovery, all that testing, it's not just for making sure you can post a photo online. This is the bedrock that supports our most critical systems. We're talking about utilities like electricity and water, banking, emergency services, the phone network, air traffic control, the things that absolutely, positively cannot be allowed to fail. Because at the end of the day, when these critical systems fail, the consequences are just massive. It's not just about losing money or a company's reputation, though that's part of it. In the most serious cases, it can literally put lives at risk. That's why system reliability isn't just some nice-to-have feature. It's an absolute necessity. So that kind of leaves us with one last question for you to think about. I mean, how could this way of thinking, understanding system reliability, help you out? How could it help you avoid a disaster? Or maybe even save the day in whatever you end up doing in your future? It's definitely something we're thinking about.